Rømer's observation, the collapse of light speed constancy. Many people understand Rømer's experiment like this. When Earth is closer to Jupiter's moon Io, light takes less time to arrive. When Earth is farther away, light takes more time. So the speed of light is constant, and the time delay is just because of distance. Sounds reasonable, right? But there's a critical misunderstanding hidden here. The assumption is that Earth is stationary, as if there are two fixed Earths, one near Io and one far away. But in reality, Earth is never stationary. It's constantly moving, orbiting the sun. And that means it's also constantly changing position relative to Io. The 22-minute delay that Rømer observed wasn't just about distance. It was the result of Earth's months-long orbital motion, accumulating over time. Earth is moving every second, every moment. So when light leaves Io and travels toward Earth, Earth isn't waiting in one place. It's already moved millions of kilometers by the time the light arrives. If we ignore this motion, we fall into the trap of believing the delay is simply from added distance. Let's step back and redefine something basic. What is speed? Speed equals distance, time. Now, if the observer is stationary, that formula works as is. But if the observer is moving, things get more complicated. In that case, we must apply the principle known as Galilean velocity addition. This principle tells us the observed speed of something like light depends on the motion of the observer. If the observer moves toward the light source, the light arrives sooner. If the observer moves away, it arrives later. So unless we apply this law of velocity addition, we must go back to the fundamental. Measure the initial distance and the actual travel time. Only then can we calculate the true observed speed. Now let's imagine a concrete case. Suppose Earth is at its farthest point from Io, and Io emits light at that moment. As the light travels, Earth is moving toward Io. That means the actual distance the light has to travel keeps getting shorter as Earth approaches. So the light arrives sooner, and we would calculate that light is moving faster. Now flip it. Suppose Earth is moving away from Io when light is emitted. The light has to catch up to Earth, the distance increases, and the light takes longer to arrive. The result? We would say the speed of light is slower. That's the core insight. The motion of the observer affects the arrival time, which means it affects the measured speed. So no, the speed of light isn't necessarily constant. It's a relative value, depending on who's measuring and how. Now here's the twist. Rømer didn't claim the speed of light was constant. He only concluded it was finite, not infinite. But now we see, if his observations involved a moving observer, and if those observations produced a time difference, then the result isn't just about finiteness. It's actually a challenge to constancy itself. Rømer's experiment becomes not the proof of light speed constancy, but the first empirical crack in that assumption. But why have we missed this for so long? Because we've been trained to memorize results, not question reasoning. Most people learned 22-minute delay equals finite light speed. And that's it. Nobody stopped to ask, how fast was Earth moving at that time? What direction was it moving? How does that affect the arrival time? This is not just about physics. It's about how we study science. Even Einstein, for all his brilliance, didn't reanalyze Rømer's setup in this light. But real science is not just about knowing outcomes. It's about understanding causes. When we combine a moving Earth, relative positions, time of arrival differences, and a proper definition of speed, we get a new interpretation of Rømer's result. Light speed is not always the same. It depends on the motion of the observer. So let's say it clearly. Rømer didn't confirm the constancy of light speed. He challenged it, even if unintentionally, by showing that speed can vary depending on the conditions of measurement. And here's the deeper truth. Memorizing fast doesn't mean understanding deeply. Slow thinking leads to deep insight. It may look slow, but it's the fastest path to the truth. And in the end, it's not how fast you move, it's where you're going that matters.